Now, the first two important generalizations that, however, also imply that the model is not analytically solvable anymore are that depreciation is assumed to be less than full and that the utility function is not necessarily logarithmic, but more generally isoelastic. So in this case, we would have that income and substitution effects do not cancel out each other anymore. And that, of course, leads to much more complicated dynamics because there are interactions between technology shocks, the transitional dynamics of capital accumulation, which is due to the fact that capital does not depreciate anymore fully between two time periods. And in general, investment and employment are then more responsive to shocks, and you can have more sustained deviations from the long run trend. And in addition, the third generalization that was present even in the basic real business cycle model was that there is not only a technological shock, so a technology shock that hits the economy, but also governmental spending shocks that can be written down in the way it is done here, so that the logarithm of governmental spending would be the logarithm of initial governmental spending, then there would be some growth of governmental spending related to population growth and technological progress, basically. And then there would be the policy shock, in a sense, G tilde, that is again an autoregressive process of order 1. And again, there is an auto correlation coefficient of rho G that could be between -1 and 1. And this equation, this G tilde, is affected by the innovation epsilon GT at time t. Now, as I said, while these generalizations lead to important improvements overall in the real business cycle model, they also lead to the situation that the model is too complicated to be solved analytically. So what's usually done is that there is an approximation of the equilibrium done by Taylor series approximation, so a log linearization around the steady state of the first order conditions. But even these linearized equations are usually too difficult to be interpreted in a meaningful way. And therefore, these models are typically analyzed numerically instead of analytically. And there, the following three steps are usually followed. So first of all, the log linearized equations are fed by empirically plausible parameter values. So for those parameter values where empirical estimates exist, they are plugged into these equations. One example is the discount factor that is typically known from empirical studies. So that's just plugged into these equations. Then there are some remaining parameters where the information from empirical studies is not so solid. So for example, the elasticity of intertemporal substitution is not really precisely estimated in the literature. And these parameters that are not so precisely estimated can then be calibrated. And calibration is then that these remaining parameters are adjusted in a way that the output trajectories that the model implies, the numerical output trajectories then, fit to the observed series in reality. And by this way, one can find out whether certain calibrated parameters are at least in a reasonable range. So we know a reasonable range for the elasticity of intertemporal substitution. And if the calibrated parameter is outside of this reasonable range, we would think that something in the model is not yet well specified. If such calibrated parameters, however, are in a reasonable range, then these models can be used to perform impulse response analysis. So basically shocks are simulated and their impulses, so this impulse, the response to this impulse of the system is then traced through the following quarters. So we have basically an impulse, a shock, and then the economy reacts in a certain way. And these reactions in terms of all the output trajectories of the endogenous variables is then traced and interpreted. How do these impulse response functions look like? Now, in this picture, we see for a canonical model, basically, the impulse responses to a 1% technology shocks as deviations from the trend over the following 40 quarters. Now, what I've done here is to simulate a positive technology shock of 1%. And this technology shock basically slowly dies out. So we have this impact effect, which is 1% deviation, and then the economy converges back to the long-run balanced growth path, where this deviation becomes smaller and smaller, but it's autocorrelated, and therefore we have the process dies out slowly. Now, this positive impact, what we would expect is that it raises wages. Now, wages are here in the third diagram, and indeed wages increase. They increase further after impact, and then they slightly decrease in the long run. Now, this increase in wages leads to an increase in employment. So this dotted line here is labor supply. So individuals increase their employment because they face higher wages due to this technology shock, and they work more. In addition, they start to save more, which leads to an accumulation of physical capital. So that's this dashed line here. And of course, this variable cannot jump, it's predetermined, so physical capital accumulates, and then at some point the deviation from the baseline reaches a maximum, and then it starts to decrease again. Now, this of course has an impact on capital income, because individuals earn interest income on their capital stock. And this additional capital income also allows them to work less actually later on. So they saved more when the wages were rather high at the beginning. And this basically allows them later on to reduce their labor supply and enjoy more leisure, because they were able to accumulate more assets and therefore enjoy higher capital income later on and reduce their labor income. What we also see is that initially the interest rate, this is the dashed line here, increases because we have the technology shock that increases the productivity of labor, and therefore the interest rate would increase at impact because the capital stock does not jump upwards. But as capital accumulates, the interest rate then again converges back, and in the long run even decreases slightly below the baseline level, because capital accumulates so fast. And output itself very much follows the technology shock. So that's very similar dynamic that we observe here. And individuals can also then consume more because they have more income, but they don't consume the full additional income, instead only a part of that, because the rest is used to accumulate capital to be able to enjoy more consumption later on and more leisure later on when the technology shock already dies out. So this would be such an impulse response to a more general real business cycle model. And as we see here, at least these responses make some sense. Well, but that the impulse responses look reasonable and have reasonable shapes is not a proper model evaluation yet. So what is done usually in the literature is to feed the model the total factor productivity series that are constructed from the data. So the model has per capita GDP. We know per capita GDP, we know capital input and labor input. We assume a coefficient alpha, and from that we can reconstruct a total factor productivity series by means of a growth accounting exercise, basically, and feed this total factor productivity series back into the model to see which responses the model generates to these shocks. And the results then, in terms of the variability of per capita GDP, of consumption, investment, labor supply, and so on and so forth, can then be compared to the variability of these series in the data. And that somehow evaluates the macro fit of these frameworks. So the empirically measured moments in the data can be compared to the model's prediction. So what do people usually find when they perform such an exercise? And here I refer to the results of Hansen and Wright in a paper from 1992, where they compare the standard deviation of certain variables x for the United States with the output of their real business cycle model. Now what they find is that the standard deviation of GDP is 1.92 in the data and 1.3 in the model. So that's kind of not too far away from the true value, and qualitatively at least it goes in the same direction. Then they compute the ratio of the standard deviation of consumption to the standard deviation of output to assess whether the model predicts that actually consumption is less volatile than output, which is exactly what we would find in the data with the standard deviation of output being a little bit more than twice as high as the standard deviation of consumption. And the model actually predicts also qualitatively this finding, while in the model the consumption is even less volatile than in the data, basically as compared to output. The same can then be done for investment, and investment is actually much more volatile than output. Investment is the component that decreases usually quite drastically in downturns, and therefore investment volatility is much higher in recession, or in general actually, than output itself, because output also is used for consumption, so consumption basically dampens the fluctuation to some extent in output. And what we see here is, again, the model predicts higher variability in investment, and it even predicts slightly higher variability in investment as compared to GDP and as compared to the United States data. But qualitatively and also it's qualitatively it's fine, and quantitatively it's at least in the ballpark of plausible values to some extent. Then, however, the variability of employment with divided by the variability of output, that's kind of somewhat underestimated by the model. So we have in the data that's close to 1, so employment would be as volatile as output, but in the model employment would be only half as volatile as output. And of course, this can be due to the fact that we only have voluntary unemployment in the real business cycle model. So it's an optimal labor supply response, basically. And we do not have involuntary unemployment in the framework. So all of this variability is just due to optimal decisions of households to kind of intertemporally shift their labor supply. And then we have a correlation between employment and per capita output, basically, that is close to 0 in the data. If at all, it's slightly negative, but the real business cycle model actually predicts a very high positive correlation between employment and output, and this can not be seen in the data to the same extent. So basically, we can say that the real business cycle model is able to capture some aspects well, that consumption is less volatile than investment and so on, but some aspects are not as well captured by the model, and it underestimates variability of output somewhat, basically. Now we can assess this critically. What's the main advantage of the real business cycle model is that it indeed was the first framework to properly address the Lucas critique. It's micro-founded. All the responses are basically derived from optimal decisions of households, so they are not ad hoc statements or something like that. It's really micro-founded, and behavior of households is optimal. The cycles are driven by random shocks, and the private response to these random shocks is optimal, as we said, and that has led to one of the crucial critiques on the real business cycle model, that actually the huge unemployment that we see in the real world, and to which I alluded to on the previous slide, would actually all be explained by optimal private labor supply decisions. So actually, and this was labeled in that way, the Great Depression would in fact not be a depression with a lot of involuntary unemployment, but it would be something like a great vacation where people just see, wages are not so high anymore, so I just go on vacation, and later on, when the economy is recovered, when productivity is higher again, then I go back to work and earn higher wages. And obviously, this is not what we had observed during the Great Depression, or for that matter, any recession that we observed in the past. So that's one of the main critiques on the model, and we will see later on how this can be addressed. then monetary policy is completely absent in this framework. But even if it was introduced, so if we allow for money and prices, then under the assumptions that we have in the framework with perfect competition, perfect foresight, and no frictions, monetary policy would have no effect whatsoever. So any increase in the money supply would lead to an increase in prices to the same extent that would offset, these effects would offset each other, and nothing in the real economy would change due to monetary policy. But we know actually empirically and just from experience that monetary policy is very important in the real world. So this is also kind of a highly damaging critique on the real business cycle model, I would say. Then fiscal policy has an impact in the model. So if the government increases spending, this has effects on real output. But these effects can never be kind of welfare improving. So if there is a downturn and the economy increases its spending, it would just influence optimal decisions of households in another way. So fiscal policy would have an impact, but it would not be welfare improving. So that all basically are really severe critiques, actually, if we take such a model completely literally. But if we take this model not too literally, but just interpret it as one step of getting new insights, then it is at least isomorphic to many other more realistic models, actually, and it can be generalized in various directions to become more realistic and at least to address some of the critiques that have been mentioned above. And as such, it's the starting point actually for most macroeconomic models of fluctuations. In particular, it's also at the core of all the DSGE models that central banks use in their assessment of different policies. However, overall, the model leaves many puzzles, and I will, on the next few slides, describe some of them in more detail and also give a hint of how these puzzles can be solved. One issue we've already touched upon is the variability of employment. This variability is much higher in the data than the model predicts. Now, there are a few solutions that one can follow. The first one would be to choose a high Frisch elasticity of labor supply in the utility function of individuals, so that individuals would be more willing to react to a wage increase in terms of higher labor supply than with a lower Frisch elasticity of labor supply. The problem with this solution is that it is not fully consistent with microeconometric estimates of the Frisch elasticity of labor supply, which is typically lower than the one that is required to bring the variability of employment in the model to the same level as it is in the data. But there is a potential second solution to that, actually, and that is to assume that labor supply or labor itself in the model is indivisible. So individuals cannot choose to supply 1 hour of labor more per day, say, but they can only choose to either supply 8 hours per day or nothing at all. So either to supply labor or to be voluntarily unemployed. In this case, the Frisch elasticity of labor supply is higher for this choice at the extensive margin, so whether to supply labor or not, and the model would be more consistent with the data on the Frisch elasticity on the one hand and the variability of employment on the other hand. But there is also a potential third solution, and that is to introduce involuntary unemployment, basically, which we will see later on. The second puzzle relates to productivity itself. Productivity shocks are the main driving forces of the cycles actually here. But if they are so important, then this begs the question where they are and why don't we read about them all the time in the newspapers? And that's what some economists have asked. And even more general, what are actually negative productivity shocks? In case of positive productivity shocks, we could think of technologies that might unexpectedly be introduced, but negative technology shocks are really something that is not that common actually. And if we go away from this interpretation of technology, then we might think of oil price shocks, or traffic congestions have also been suggested in this regard, but they would not be so high that they can explain all the fluctuations that we observe. So in general, the productivity shocks that we observe are not so large that they can explain all the variation of output in the data. Now, there is one potential solution to that, namely to allow for variable capital utilization. What is this? So in the basic model, employment was the only variable that was allowed to react instantaneously to productivity shocks. So people would supply more labor if productivity goes up, and this was the main adjustment mechanisms that were available. And capital could not adjust instantaneously because it's predetermined. But if we assume variable capital utilization, then what we would have is that a machine could stand idle, for example, and it might not be employed at a certain moment in time. So the capital stock would exist, but the machine would not run. This can be captured by assuming a variable z in the production function that relates to capital, and z could be 1 if there is full employment in the capital stock, but it could also be lower than 1, then we would not have full capital employment. And then also capital employment could react to exogenous productivity shocks. In this case, the propagation mechanism actually in the model increases so that even smaller technology shocks can create higher fluctuations, actually, or stronger fluctuations. And of course, the second potential solution is always to introduce additional shocks, which we will also see later. Then there is a high and positive correlation between productivity or wages and employment that is not observed in the data, and there it's potentially even negative. Now here the problem could be that in a recession, the wage rate might not necessarily be equal to the marginal rate of substitution between consumption and leisure, as it is implied in the model. Now, a solution to this would be to introduce a wedge between the two, so that particularly in recessions, the wage rate and the marginal rate of substitution between leisure and consumption would not be equal to each other. So this wedge is here represented by tau LT, and this could capture all kinds of labor market imperfections. For example, it could capture the effect of labor unions that have an influence on the rigidity of wages in such a model. General wage rigidity is that they might not decrease in a recession that much, and so on and so forth. And all that could help to solve this puzzle with respect to the correlation between productivity and employment. Another problem is that there is no involuntary unemployment in the model. As we have seen, that leads to the critique, of course, that recessions or even the Great Depression is actually not such a Great Depression, but more a Great Vacation. So people choose voluntarily to become unemployed. And of course, this is not something that we would observe in reality. So people are involuntarily unemployed as well. And so the solution is to introduce elements of modern labor market theories that explain unemployment to some extent. So efficiency wage theories basically that explain why some firms might pay higher wages than the marginal product of labor actually to address problems with respect to shirking and so on. And that, of course, leads to involuntary unemployment because some people would not get employment at these higher wages that would want to have an employment. Labor unions and wage bargaining mechanisms that raise the wages above the marginal product of labor could also play a role here, and particularly also search and matching aspects actually that have been introduced by Mortensen and Pissarides, but they have also been introduced into real business cycle models or DSGE models more generally, and would then explain equilibrium unemployment by these surge frictions that emerge on labor markets when people should search for jobs and firms search for workers, and then a certain match has to be found. And finally, there is the problem that monetary policy is absent, so there is no money in the model. But even if we introduce money, monetary policy would be ineffective. It would just raise nominal prices and nominal money supply, and in the end, everything would cancel out. There would be no real effects. And the solution here is to introduce money in the first place and then nominal friction so that prices cannot adjust instantaneously in the model. And then during the time when prices adjust to their new equilibrium level, there could be real effects of monetary policies. Now, most of modern DSGE models that central banks use, basically all of them, have a new Keynesian Phillips curve somewhere where in the short run, output can be affected by unexpected shifts in inflation or in monetary policies, basically. But in the long run, the trade of inflation and output vanishes and breaks down, because then in the long run, the economy adjusts to the new equilibrium, and in the long run, money would be neutral in such frameworks. Now, to summarize, what we've learned is basically that modern macroeconomic models are micro-founded. They take the Lucas critique into account and address it. Modern growth and business cycle analysis, they have the same foundation. So at the core is a Ramsey-Cass-Koopmans model, and the long-run balanced growth path is actually the same in both of these frameworks. What real business cycle models add is the fluctuations around the trend in the short run. The results for the long run, however, are basically the same. Now, with respect to short-run fluctuations, there are some questions that remain to be answered. Which frictions are important? How important are monetary policy versus fiscal policy? Which shocks can drive business cycle dynamics? Whether also nominal shocks can drive business cycle dynamics, and so on. And real business cycle models fail to answer many of these questions. So we will next generalize them actually in the direction of new Keynesian models that allow for nominal rigidities and frictions, basically, and we will see that then also shocks to nominal variables can have real effects, and this model will be able to explain some of the aspects that a real business cycle model is not able to explain.